Hi there. We're going to take a look at basic polynomials here. Let's go over some definitions. A monomial is a number, a variable, or a product of numbers of variables. So 8x, negative y squared, 3mnx squared y, they're all monomials. In other words, they're not something plus or minus something else. The coefficient is the number in front. So if we have 20x squared, the coefficient is 20. And a polynomial is exactly what I just said a monomial isn't. It's one monomial plus or minus another monomial plus or minus another monomial. So here are polynomials, and they can be classified in two different ways. One is by the number of terms, and the other way of classifying them is by their degree. So the degree is the greatest sum of exponents in any one term. So let's take a look at this. When we look back up here, let's talk about what the exponents of these variables were and what they add up to. So here we have m to the 1, n to the 1, x to the 2, y to the 1. So that's 1, 2, 3, 4, 5. The degree of this term is 5. So that's what a degree is. And when you look at number of terms, terms are separated by plus and minus signs. So this will be 2 terms, this will be 2 terms, this will be 1, 2, 3 terms, and this will be 1, 2, 3, 4 terms. So let's just write that in, 2, 2, 3, and 4. Now here, in order to find the degree of one term, we just did that up here, but if you want to find the degree of the entire polynomial, what you do is you did what we did to find the degree of the term, and you do it for each term, and then you write down the largest number. So this, for example, has a degree of 2. That's an x squared. This has a degree of 1. So what's bigger, 2 or 1? 2, obviously, so you write down 2. So the degree of the polynomial is really equal to the degree of the term with the highest degree. So let's take a look at these. This is a 2, this is a 1, so that's 3. This is a 1, 2, 1, 3, so that's 3, 4, 5, 6, 7. So 7's obviously bigger than 3. Here, there's no degree. Here there's 4. There's 3, so 4 is the number. And then here is 5, 3, 2, and no variables, so 5 is the number. So I know that's not difficult, but if you didn't know it before, now you do. Let's take a look at simplify and evaluate. I don't know why it says evaluate twice, really evaluate. Okay, so here we have this, and we want to evaluate when x is equal to 2. So we did this during our preview, but let's do this kind of thing, but let's do it again. So we have here 3x, which is 2, and then we have x plus 1, and x is 2. And then we have x squared minus 3x. And that's what we're looking for. So let's simplify here. Here we have 6, and here we have 3. Then I have minus, and then 4. And in these brackets I have 4 minus 6. 4 minus 6. So that's 18. And 4 minus 6 is negative 2, and negative 2 times negative 4 is positive 8. So we have a grand total here of 26. All right, next. Write each polynomial in descending order. So what's descending order? We mean the variable's exponent, put the biggest one first and then go down. So here we have x to the 5, so we'll write this, minus 5x to the 5. Then we're going to descend down to the next one. Are there any x to the 4s? No. Any x to the 3s? Yes. Plus 4x cubed. Then x squared minus 2x squared. Then x. Then 6. And then we do a double check to just make sure. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. We've done them all. Okay, so here we're going to go descending order of our degree. Oh no, we're going to go descend. We're going to answer the question. We're going to descend in order of x. So here we have an x2, x4, x to the 3, x to the 5. So x to the 5 is the first one because we're descending in order of x. So that's x to the 5y. Then we have x to the 4, our term with x to the 4. Then we have our term with x to the 3. Then we have our term with x to the 2. And then we have our term with x to the 1. Now let's take a look. What does it say? To add polynomials, we collect like terms. So first thing to do is get rid of the bracket. So let's do that. 3x squared plus 2x minus 6. And then here, this is positive. If it was negative, we would change the sign of everything in the bracket, but it's not. So let's just add this up. And now we're going to collect like terms. There's the x squared, so that's 3 plus 2 is 5x squared. Then we have the x's. 2 minus 4 is negative 2x. And then negative 6 and plus 7 is plus 1. Here we're going to deal with the negatives. So remember, we're going to have to change the sign of everything in this bracket. So let's see here. 5a squared b plus 2ab minus 3b squared minus 6a squared b minus times minus is plus 3ab minus times plus is minus b squared. So here a squared b. Are there any other a squared b's? Yeah, there is. Good. So 5 minus 6 is negative 1a squared b. Then we have an ab and an ab. So 2 plus 3 is 5 ab's. And then we have minus 3b squared, and minus 1 is minus 4b squared. And you'll notice it's a to the 2, a to the 1, and no a's in descending order of a. Okay, let's do this one as well. So here we have 3x squared minus y minus 6, and then the negative means change the sign of everything in the bracket. So we have negative 2y squared minus 5y plus 7. Now we're going to collect like terms. 3y squared minus 2y squared is 1y squared. Negative y and negative 5 is negative 6y. And negative 6 plus 7 is plus 1. All right, a little more on polynomials. So here we go. To multiply polynomials, multiply the numerical coefficients, then multiply the variables using the exponential rules for multiplication. So first we're going to multiply the numerical coefficients, which is 3 times negative 2 times 2. And then we're going to multiply the a's. So we have a cubed, and then we have b squared, and nothing else. So let's do this here. 3 times 2 times 2, and one of them is negative, that's 6 times 2 is 12. A to the 1, a to the 1, a to the 3, that's 5 of those, and that's b cubed. Okay, so with that demonstrated, now I'm going to give you a couple seconds to get started on that one, and then we'll take it up. All right, here we go. So we're going to do negative 6 times negative 5, and then x squared, and then y times y cubed, and then z times z. So here we go. Negative times negative is positive 30, x squared, y times y cubed is y to the 4th, and z squared. Okay, dividing. So we just multiplied. We're going to do the same thing with dividing, except of course we won't add the exponents. We'll subtract them for like bases, and instead of multiplying the coefficients, we're going to divide them. So here we've got negative over negative is a positive. 21 divided by 7 is 3. And then we have x to the 2 minus 1. So 2 minus 1 is 1. Then we have y squared over y squared is canceled, and z over z. So the whole thing is equal to 3x to the 1, or as we would actually write it, is just 3x. Here, let's try this one. So we have negative over positive, so it's negative. So I do the signs, then I do the numbers, and then I do each variable on its own. 32 over 8 is 4. P to the 2 over P to the 2, anything over itself cancels. And then Q to the 4 minus 3, 4 minus 3 is 1. There you go. Now let's take a look at multiplying polynomials by a monomial using the distributive property to multiply each term in the polynomial by the monomial. So for example, what we're going to do, I'm going to write it out here, this first one in long form. So I've got 3x times x squared. Then I've got 3x times 2x. Then I have 3x times negative 2. And then I'm going to do the same here, plus 2x times 3x squared, plus 2x times minus x, plus 2x times minus 4. And now I have a whole bunch of mini little multiplications to do. So this is equal to 3x cubed, this is equal to 6x squared, this is equal to minus 6x plus 6x cubed minus 2x squared minus 8x. So now I have some collecting to do. I'm going to do it right here because I'm running out of room. So I've got 3x cubed and 6x cubed is 9x cubes. Then I have 6x squared minus 2x squared is plus 4x squared. And then I have minus 6x and minus 8x is minus 14x. Now, you get started on that one, and I'll catch up to you in a minute. So you can try it without watching and actually do it yourself. Okay, I'm going to join you. So that's 4m times m squared is 4m cubed. So I'm just going to go straight to this line. Again, you do this if you see that you make mistakes or you're not comfortable with it, but you can go straight to here. Remember, I'm always going to tell you what is okay to skip and what is not okay to skip. So here we've got 4m cubed, then we have minus 4m squared n, and minus 4m n squared, minus 12 m squared n. Always put your variables in alphabetical order. Then plus 2m n squared, plus 8n cubed. Okay, let's see what's like terms. Here, I think there's only one m cubed. How about m squared n? M squared n. Oh, there's another one. So I've got minus 4 and minus 12 is minus 16m squared n's. Then I've got mn squared, mn squared. Minus 4 plus 2 is minus 2mn squared. And then I have this plus 8n cubed. Now let's take a look at this one. For the rectangular prism here, so we know what prism means. It's a rectangle with depth or with height. Okay? So a rectangular prism, write the expression that represents the volume and the surface area. So the volume is length times width times height, and the area, the surface area, is the area of all the surfaces. So we're going to have, for area, we're going to have 2 of these on each side of the box. So that's 2 of this times this. So 2 length times widths. Oops. What am I doing? Hang on a second. Surface area equals 2 length times widths plus. Then we're going to have 2 of these, one in the front, one in the back. So that's 4y by 2y. So we're going to have 2 lengths by height. And then we're going to have this top piece and this bottom piece, which is 3x by 4y, or width, 2 width times heights. Okay, well let's continue with this and then we'll go back to volume. So here we've got 2y by 3x, and then we have 2 4y's by 2y's, and then we have 2 3x's by 4y's. Okay, so that is this times this times this. This is 4 times 3 is 12 xy. And then we have 2, 4, 2. So 2 times 4 is 8 times 2 is 16. Y, so that's y squared. And then here we have 2 times 3 times 4. So that's 6 times 4 is 24 xy. So do we have any like terms? Yeah, we have 2xy, so we can collect those. So 12 plus 24 is 36xy plus 16y squared. And this is area, so we're going to write units squared because we're not given any units, but we want to communicate that we know that it's area. So we've done there are 6 surfaces of this cuboid or this rectangular prism. Just think of like a tissue box or Kleenex box. There's 6 faces. 2 are this size, 2 are this size, 2 are this size. Add them all together, you get all the different sides. Here we're going to do volume as length times width times height. So we've got 4y times 3x times 2y. 4 times 3 is 12 times 2 is 24. Y times x times y is xy squared, and that's units cubed. And that is our first lesson on polynomials.